In this video, you'll learn how to use differentiation to find small changes and how to find rates of change. Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we'll look at a question from Volume 5, Chapter 2, Differentiation. So as usual, you can take a look and try it by yourself first. In this question, we can highlight this line RQ is parallel to the x-axis, which means it is a horizontal line and the length is p units. So for part A1, we need to find the area of the triangle RQS in terms of p. So this will be our triangle. We just need to find this length and this length. So this length is p units. But for this length, we need to find the y-coordinate of R, which is the same as the y-coordinate of Q. And for Q's x-coordinate, you already found, which is P. So we just sub P here. And for the 4P squared, we can minus the y-coordinate of S. And we can use 1 over 2 times base times height to find the area of this triangle, which is 2P cubed minus P. So for part B, it is given P equals to 2, we need to find the corresponding change in A, which means a small change in A when P increases by 3%. So to find the small change, we need to use this formula. Since we need to find the small change in A, so replace the Y with A, and since P is related to A, so I'll replace the X with P. So now we need to find dA over dP and delta P. So for dA over dP, we can actually use this equation because it says in the question, hence. And remember, when differentiating, we need to separate this equation using positive and negative. So differentiating this, we'll multiply the power and the number. And power minus 1. And here we can just extract the value. And for delta P, we can use the information from here and an equation, which is the percentage change in P equals to the change of P divided by the original value of P multiplied by 100. So in the question, they've given us these two and we need to find delta P. So we can just sub the value inside, which delta P is 3 over 50. And now we can sub these two information into the original equation. For the P, we need to sub the original value, which is 2 in this case. So our answer means if we increase P by 3%, our area will increase 1.38 cm squared. And in part B, it says using the value of P used in A2, we need to find the rate of change where the distance of point R from the x-axis when P increases 0.03 units per second. So I plotted the lines and the curve inside that SMOS, and the red line represents the length from point R to the x-axis, and the blue line represents the line RQ, which has length of P units. So y'all can see that if P increases, our blue line will increase, followed by the red line. So the question asks, if P increases per second, how much does the red line increase per second? So to find the rate of change for the red line, it can be represented as dH over dt, and we can use chain rule to split this fraction. And for the blank spaces, we need to find an unknown, which is not in the equation, but in the question, and has a relationship with H. In this question, it will be P. So here I'll put dP. So to find dH over dP, we have an issue, because we don't have an original equation which relates H and P. So let's go back to the diagram here. As we know, if we want to calculate the length H, we need to find the y-coordinate for this point and deduct. So H actually depends on y. For P, it's the same as well, but it depends on the x-coordinate for these 2 points. So P actually depends on X. So the relationship of H and P depends on the relationship of y and x, which means we can also use dy over dx to find this. And luckily, this curve has an equation y equals to 4x squared. So you can differentiate this to get dh over dp. So value multiplied by the power, we will get ax and power minus 1. And to translate it into dh over dp, we need to change our x to p. For dp over dt is actually one of the things we highlighted just now, which is this. So dp over dt equals to 0.03. And now we can multiply 8p and 0.03 to get dh over dt. So our answer would be h changes 0.48 units per second. And with that, we have completed this question. So part A2 actually involves the third application in differentiation, and part B involves the last application, which is small values and approximation. So the take-home point for this video is, when it comes to rate of change questions, we need to use chain rule to split this fraction into 2. And for the blank spaces, we need to find an unknown which is not in the equation but in the question. And we need to make sure the unknown is related to the y. So dx over dt will be given, but dy over dx we need to differentiate the original equation. And for small changes in approximation, we need to find two things as well, which is dy over dx and delta x. So dy over dx we need to differentiate to obtain, and sometimes delta x will be given in the question, or we need to use the second formula, which is the percentage change in x equals to changes of x divided by the original value of x multiplied by 100. And lastly, to find the approximate value of y, we need to add up the original and the change. So if you're interested in this question's answer scheme, you can click the link in the video description, and if you feel this is beneficial to you, please give a like, subscribe and share it to your friends and classmates. So I'll see you very soon in the next video. Thank you.